the radioactive radiations are emitted from the nucleus, and the three types of radioactive radiations which are emitted out from the nucleus is known as alpha, beta, and gamma. So if you have alpha particle, basically alpha particle is also known as a helium nuclei. Why? Because alpha particle is a combination or a group of two protons and two neutrons. Beta is electron. So what happens if there's alpha emission? That we'll discuss in decays. But the second question, so alpha particle is a sum of two protons and two neutrons. So what is beta? Beta is electron. There are two types of beta decays, but you're learning only one of them. This is called a negative beta decay or electron. Now my question is that if I draw the atom, whenever we draw the atom, what we do? We draw the nucleus. Inside the nucleus, we have nucleons such as neutron and protons. And around the nucleus, we are drawing electrons. So alpha particle, we understand that alpha particle, two proton and two neutrons are coming out. But beta particle is electron. So from where this electron is coming, even though we don't see an electron inside the nucleus. So how electron is produced, even though it is not present, but how this electron is emitted. So basically what happened, how this electron is emitted, anyone want or having any idea about this? Want to share? Otherwise I will explain. Anyone want to answer this? How?
Reactions.
Basically what happened, no, the electron, this electron is from the nucleus. This electron is emitted from the nucleus. Sorry, this outer shell electron, this is in the orbit, but the beta is always emitted from the nucleus. So it's not there are electrons outside the nucleus, but this electron is specifically emitted out from the nucleus. So basically what happened, a neutron, which is not a fundamental particle, it means not a fundamental particle means it can break down into smaller particle. So what happened, a neutron breaks into proton and electron. So one of the neutron here, for example, the neutron here, it breaks into what? It breaks into proton and electron. And that electron is coming out. And when this electron is coming out, how this neutron break? Because the particles are continuously colliding with each other because of lack of space. Due to the lack of space, these particles are continuously colliding inside the nucleus. So this is a nucleus. A nucleus consists of neutron and proton. So there are neutrons as well, and these particles are not stationary. These particles are colliding with each other. So as these particles are continuously colliding with each other, what it causes? It causes the breakdown of a neutron. And when this neutron break down, what we observe, that this neutron break down into proton and electron. And this electron, when it will go out, what we call this electron, the electron which is coming out from the nucleus, this electron is known as beta. So electron is not present in the beginning, but it is only produced when there is a breakdown of the neutron. It will increase the number of the proton in, not in the shell. To break, there must be energy. From where they will get energy? These particles, because there's a repulsion, so there is a force between them, and whenever there is a force, there is energy. The electrostatic force is there between the proton and neutron also. there is a force which is called strong nuclear force. So that electrostatic repulsion and the strong nuclear force contribute to breakdown of this neutron into proton and electron. So what happens when there is a beta decay? The proton number increases. Number of the proton increases. So after a beta decay, it can emit out more radiation, but this is a probability, or the chance is there that the neutron can break into proton and electron, and we call this as a beta particle. Is it clear? The emission of a beta particle, the origin, how this beta particle is emitted? Yes, Afif?
Sir, like the question I'm about to ask, it might make no sense, but like,
Okay.
aren't these neutrons like, aren't they supposed to be indivisible? Like they're the smallest
No.
thing.
Actually, you will learn that neutron and proton are not the fundamental particle. The only fundamental particle, this is extra thing, not related to a topic. There are 12 fundamental particles. One is called a lepton family, which include electron, electron neutrino, tau, tau neutrino, muon, and muon neutrino. And there is a quark family, which is having up, down, top, bottom, charm, strange. So these are the only fundamental particle. There are 12 fundamental particles. Other than these 12 fundamental particles, all are particles which can break down. Neutron and proton can break. Even proton is not a fundamental. Proton can also break down into a particle known as neutron and positron. But that is not part of your course. That is called a positive beta decay. That is why I'm not making you confused and going in detail of this. The only one decay you are studying, you are only learning the breakdown of neutron into proton and electron. So there are 12 fundamental particles. Yes, anyone was asking a question? Any question?
No, sir. Like, thank you very much, sir.
Okay.
Thank you.
So basically, as you learn in like class 7 or 8, you learn that proton, neutron, and electron are fundamental particle, but it is not true. Neutron and proton are not fundamental particles. They can break down into further particles. A particle which cannot break down into further smaller particle, that particle is known as fundamental. And there are 12 fundamental particles. One is called a lepton family, another one is known as the quark family, but that is not included here. So you just have to understand the fact that the neutron, because of the space, lack of space, collision between the particle, this can lead to breakdown of a neutron into proton and electron. And this electron is actually known as a beta particle. Yes, as the number of the proton increase in the nucleus, it will not make the nucleus stable. A beta decay is not making nucleus too much stable. But the thing is that this can also happen due to the limited space available for the particles. So this decay can also happen. And what is a gamma? A gamma is actually energy. It is not a particle. It is release. When the nucleus is emitting out energy, we call that as gamma radiation. Because what happened, like this is a nucleus. If the nucleus is stationary, what is the initial momentum? If nucleus is stationary, not moving, what is the starting or initial momentum? The momentum will be zero because it is not moving. Now, when it emit out alpha particle or beta particle, so if alpha particle is moving, example, towards right, so which direction the nucleus should move to conserve the momentum? So the nucleus should move towards left. because it has to conserve the momentum. So what happened when the nucleus is moving, it releases energy, and that energy we call that as gamma. So energy, it is not the particle, it is energy actually emitted from the nucleus, which is having a very high frequency and shorter wavelength, which is harmful for human body if it is exposed for even a short term. Long term exposure, it's very harmful. A short term can have acute effects, but still it is harmful radiation which is released from the nucleus. So three type of particle, two particles are emitted from the nucleus, and one radiation is emitted from the nucleus. So gamma or energy is released, and it is always associated with the movement of the nucleus. So whenever there is alpha decay, whenever there is alpha emission, there will be a gamma emission. Whenever there is a beta emission, there will be a gamma emission. Or it might, a nucleus is vibrating. If a nucleus is vibrating or moving, in that case also it emit out gamma. So gamma is the energy which is released from the nucleus. So these are the three types of radiation: alpha, beta, and gamma. Alpha and beta are the particle, where gamma is the energy which is released from the nucleus. So that will not, that is only because when the nucleus will have low energy, when particles, charges, atoms have low energy, so they become stable because it is not vibrating too much. Like for example, if you have a container which is filled with say marble balls, and you're moving it, if it is completely filled and you're moving it, so what happened, the glass or the jar might break. So same thing happen when the nucleus is releasing energy, so it does not vibrate too much. So when it does not vibrate, it also get stability. Is it clear, the concept of these emissions, alpha, beta, and gamma? Gamma is energy released by the nucleus. What happened when a nucleus is emitting out radiation, the nucleus move. As the nucleus move or the nucleus vibrate, it tend to emit out energy because it has to slow down. So what have, because it cannot go outside the atom, so when it slow down, it release its energy. When it release energy, that energy which is released by the nucleus is refers to gamma. So there is alpha, which is 2 proton, 2 neutron. There is a beta, which is called electron, and there is a gamma, which is energy released from the nucleus. Is it clear? Where gamma is always there, even alpha. Gamma is, that's why, like when you have a radioactive source, you find when the nucleus is unstable, it is continuously emitting out gamma. But gamma is not the particle, it is the energy released. So you have mostly gamma radiations from the source, or continuously gamma radiations are coming out from the source. Now these decays, because we have alpha, beta, and gamma. So first, what happened in alpha decay? So what happened in alpha decay? I'm just drawing the nucleus. Say this nucleus contain 84 protons and it contain 144 neutrons. Okay. It emit out alpha. 2 protons and 2 neutrons are released. This is the starting, the beginning. After emission, After emission, how many protons will be left? Because 2 are released, so 82. How many neutrons will be left? 142. Neutrons will be left. Now, the question is, what will be the change? Atomic number. Atomic number means number of proton. How the atomic number will change after emission? It will increase by 4 or decrease by 4. What number it changes by? So atomic number will decrease by 2. And what happened to atomic mass? It will decrease atomic mass. Basically, atomic mass is a sum of neutron and proton. The total number of proton and neutron. So what will be the change in atomic mass? It will decrease by 4. Why it will decrease by 4? Because there are 2 proton and 2 neutron are emitted out. Yeah, the neutron number decreased by 2, but the atomic mass, because atomic mass is a sum of neutron and proton, that is why atomic number is the number of the proton and atomic mass is a sum of neutron and proton. So sum of neutron and proton will decrease by 4, sum of proton will decrease by 2. What will be the change in a proton number? So there are 2 protons are emitted, so it will decrease by 2. And what will be? It will decrease by 2 as well. So if we write a journal equation, this is what happens if there is an alpha decay. So if we write a journal equation for alpha decay or emission, yeah, the mass number will be, look, what is the mass number here? What is A here? A is the sum of neutron and proton. What is the sum? 84 plus 144. 84 plus 144. It's 228. What is Z here? That's 84. But what is A here? The sum of neutron and proton, that 224. And what is Z here? That is equals to 82. So you can see that the atomic mass was 228, it become 224. Atomic number was 84, it become 82. So mass number decreased by 4. Where the atomic number, which is the number of the proton, decreases by 2. So this was -2, this is -4. So if we write a general equation for alpha emission, so any element is there represented by symbol X. A is atomic mass, Z is atomic number. It emit out alpha. This is a symbol for alpha. 4 and why 4 and 2? Because alpha is 2 proton and 2 neutron. So 2 proton, 2 neutron, the mass is 4 and atomic number 2. It because the atomic number change, so the whole element will change. What will be A? A will be -4 and Z will be -2. Is it clear? Like atomic mass will decrease by 4 and atomic number will decrease by 2. And that is the general equation for any kind of alpha decay. Like, for example, if I say an element X was having 214 or 220 and 86, it emit out alpha. What will be the mass number for element Y? If it is 228, this is 228. Sorry, 220, not 228. This is, I took 220. So this will be 216. And if it is 86, this will become 84. So you should be able to complete the equation for the decay, alpha decay. Sometime you have to complete for reactant side, sometime you have to complete for a product side. So this is known as alpha decay. Atomic mass decreases by 4 and atomic number decreases by 2. The second one is a beta decay. A beta decay, like example, you have a nucleus. Say it is having 140 neutrons and it is having 92 protons. And it emit out beta. Beta means electron. So how a beta is emitted out? There are 140 neutrons. Out of 140 neutron, one of the neutron, example, breaks into proton and electron. So this is at the start or at the beginning. And after emission, how many neutrons will be there? If 140, so it will be 139. That's right. And it will be 93 protons will be there after emission. What is A here? A means the sum of neutron and proton. What is the sum here? 140 plus 92. That's equal to 232. So that's equal to 232. So there are 232 nucleon, and what is Z here? It's 92. What is A here? 139 plus 93. Neutron number decrease, proton number increase, so the sum will remain same. But Z, because the proton number increase, so it will become 93. So now what happened when there's a beta decay? When there's a beta decay, what will happen to neutron number? What happened to a neutron number? It decreased by 1. What happened to proton number? It will increase by 1. What happened to atomic number? It will remain same. And what happened to what happened to atomic number? It increased by 1. And what happened to atomic mass? It will remain unchanged, or it will remain same. If we write a general equation for this decay, like we wrote for general equation for alpha, so we can write for general equation for beta. So for beta decay, because first thing, the element which is radioactive, like element X is a radioactive element, A and Z, when it emit out beta, this is a symbol used for beta, 0 and -1, because it does not have any neutron and proton, that's why 0. And it is electron, so charge is -1. So it turned into A will remain same and Z will increase by 1. So if I have an element X with 150 and 85, it emit out beta. Even you can write this symbol, both are acceptable. You can write electron symbol like 0 and -1, or you can write beta 0 and -1. Both are correct. What will be the mass here? 150 is there, the original mass. So what will be the mass after emission? That will remain same. And what happened to atomic number? 85. It will become 86. So this is what happened in a beta decay. In a beta decay, the nucleus is actually the neutron inside the nucleus break down into proton, electron. There is also another particle which is emitted out that is called electron neutrino. But again, that will be in detail when you will. Why there won't be a charge +1? Because what happened? You're saying like because the proton number increases and the neutron number decreases, so the net charge should be +1. But the thing is, there will be a change in electron in the shells as well, but you're not taking that in consideration. That's why you're considering it is to be neutral. Basically, practically what happened, there's a term which we call transmutation. This transmutation is not part. You're asking a question, so that's why to clear this idea, a transmutation happened. What is a transmutation? What is basically a transmutation? Look, a neutron breaks into proton and electron. Okay. The proton remain inside the nucleus. So number of the proton are already there, but because of this breakdown of a neutron into proton and electron, this proton number increases. Example, I'm just taking a small number of electrons to explain the idea. Example, this element was having say 4 electrons. So first in the 2 shell and first in, like if I take the numbers, say this was having 4 protons, 4 neutrons and 4 electrons. Reason why I'm taking a small number, so to explain the idea only. One of the neutron breaks into proton and electron. So number of the neutron will become 3 and number of the proton will become 5. So 3 neutron will be there and 5 proton. And how many electrons are there in right now? There are 4 electrons. So this should be a charge plus charge. But what happened? This electron which is emitted out from the nucleus, it will stop in the shell and it will start to revolve in the shell. So the number of the electron will become 5. So what will be the net charge? There will be no net charge on this atom. This is actually what happened. But the transmutation part, you're not studying the transmutation part. You're only studying that what happened inside the nucleus when a neutron breaks into proton and electron. Is it clear? Then the last one is known as a gamma emission. A gamma emission, when a gamma is actually energy emitted out from the nucleus, so it's not a particle. When the nucleus emit out high energy, high frequency radiation, we call that as gamma. So because there's no particle emitted out, so there's no change in element. Like element is there, X, it remain element X because there's no change in the particle if it is associated only by the vibration or the movement of the nucleus, and it emit out gamma rays. Is it clear? So for gamma, you don't have to, like, there's no change in atomic mass, there's no change in atomic number, only the nucleus is releasing the energy. But gamma is associated whenever there's alpha decay, there will be a gamma decay as well. When there's a beta decay, there will be a gamma decay. And maybe alone it can also have a gamma decay, or not gamma decay, basically gamma emission. Gamma emission is there when the nucleus is moving. So nucleus is moving when there's alpha decay, nucleus is moving when there's a beta decay, and nucleus sometimes vibrate because of energy. So that is also responsible for gamma emission. So 3 types of emissions are there: alpha, beta, and gamma. Any doubt in this part? The emissions, the decay equations? Is it clear? Then you have to learn the properties of these radiations. The first property is the mass. So what is the mass of alpha? Alpha is actually, it is sum of 2 protons plus 2 neutron. Like the mass is the sum of 2 proton and 2 neutron. What is beta? The mass of a beta. I'm not writing the exact value, but it's same as the mass of electron. Mass of electron is 9.11 exponent minus 31 kilogram. And mass of one proton is 1.67 exponent minus 27 kilogram. These values, neutron and proton, have the same mass, which is 1.6 into 10 to the power minus 19, minus 27 kg. You don't have to memorize this value. This is just an information. Mass of electron is 9.11 into 10 to the power minus 31 kilogram. So electron is a lighter particle because minus 31 is a smaller value as compared to minus 27. So electron is a lighter. Gamma is energy. For energy, you don't, that is called a relative mass. When you say 1 divided by 1840, that is a relative mass, like compared to proton and neutron. It is 1 divided by 184 times, but that not the actual mass. These are the actual masses. For gamma, it's energy. For energy, like example, if I say what is the mass of light, you don't explain or say the mass of a light, because for energy you don't define the mass. Then speed or charge. What will be the charge of according to there is a called a wave particle duality. Theoretically, energy can be changed, like energy can be changed into mass, or mass can be changed to energy. But at once, you cannot have both state. Like example, something can be a matter or something can be energy, but you don't have matter energy together. So when we are saying gamma is energy, so in that case, we cannot say gamma is a matter or it will have a mass. Because the properties of the matter are different and properties of energies are different. Like if it is energy, then it will correspond to the parameters related to energy, like wave. And if it is a mass, then if it is a matter, then it will have a mass, it will have arrangement of the particles. The charge will be positive or +2, a relative charge will be negative, and there will be no charge. The speed, when we compare the speed of alpha particle is very slow because they are more mass. So approximate speed, like the variation is there, you don't have a fixed value for their speed. So relatively alpha particles are traveling slower. And why they're traveling slower? Because of their mass. But the maximum speed which we can accelerate the alpha particle is 1 over 100 times speed of light. A beta particle 1 over 10 times speed of light. But that is the maximum speed, possible speed, which we are able to accelerate. And gamma is energy, which is speed of light. Not really, you don't have to learn this exact value. You don't have to, just understand the idea that this is the maximum speed which we are able to accelerate, but you don't have to learn these values. There's a comparison between them. So speed of light is 3 into 10 to the power 8 meter per second. Which one you can think like have a greater range? Range means the distance traveled by the radiation. So which one will have the longest range? Gamma, because of high speed. So this will have a long range. This will have moderate, average, and this will have a short range. Because of their higher speed, they will have like cover a greater distance before completely being stopped. There are more properties of these radiation, but that we will discuss in the next session. Means tomorrow we'll discuss those properties. So I'll continue this explanation. Of atomic physics. Maximum, it will take 3 classes. Maximum, it will like tomorrow class, and then next week we will finish block 5. Only 3 topics are there: radioactivity, half-life, and the nuclear reaction, fission and fusion. That's it. So radioactivity, we are almost at the end of radioactivity. Half-life we'll do tomorrow, and nuclear reactions next week. Any question or a doubt related to the class?